All right, so one of the main things we learned last chapter is that many reactions don't go to completions. It's not that you have reactants and they all turn into products. It's that you have reactants and then some of them turn into products, and then you reach a dynamic equilibrium where the two rates are equal and opposite. So this is true in many acid and bases, and so we call these acid-base conjugate pairs. So let's take a look at this. So here we have ammonia reacting with water to form ammonium and hydroxide. And so here, the ammonia is acting as a base, and then the water is acting as an acid, right? And so that's if we're taking a look at the reaction going in this direction, right? From left to right, the ammonia is the base, the water is the acid. But if we're going from right to left, then the opposite is true. Right now, it's the ammonium that's acting as an acid, and the hydroxide is acting as the base. And so what we call these are conjugate acid-base pairs. So this ammonia here is a base, and then on this other side, this ammonium is its conjugate acid. And then over here, this water is the acid when we're going from left to right, but when we're going from right to left, the hydroxide is acting as a base, so we call that its conjugate base. Right, and we can kind of match the two if we want. So they are conjugate acid-base pairs because, again, it's really about what are you talking about? Are you talking about going from left to right or right to left, right? And so here's just some more examples. Right, ammonia itself acts as a base, but whenever it's protonated, it can then act as an acid, right? So here it's a base, here's the conjugate acid, right? Water can act as an acid by removing an H+, but then if it's going in the other direction, it's going to act as a base, so it's the conjugate base. Another example, here we have HF interacting with water to form H3O plus F minus, right? Here in this direction, right, we're thinking about where the H is going. The HF is giving the H plus, it's donating the H plus. So this is the acid, this is the base, and that's if we're talking about going from left to right. But if we're talking about going from right to left, then this guy right here is the base, right? The F minus is going to take an H plus, and so we call that the conjugate base. And then this H3O plus would be the conjugate acid. And so they are conjugate acid-base pairs.